My name is Jean Wilson. I'm a Research Fellow of Geography within the School of Natural Sciences, and I work as part of the Biogeochemistry Research Group at the Centre for the Environment in Trinity. So my research interest is in remote sensing, and specifically the application of remote sensing within environmental science. So you might ask what remote sensing is. Basically it's the acquisition of information on or about the Earth's surface and atmosphere without being in direct contact with that object. So as we're speaking now, there's several hundred satellites whizzing overhead, gathering lots of information about the Earth's surface. And so what they're actually measuring is energy. And most of this energy, or all of our energy, of course, comes from the sun. So the sun emits its energy in wavelengths through the electromagnetic spectrum, and these are wavelengths of differing sizes, and they each tell us different things about the Earth's surface. So satellite systems are designed with that in mind. So the energy travels down from the sun through the atmosphere, interacts with the Earth's surface, is reflected back up through the atmosphere into space where it's detected by the sensor. And this helps us understand what's actually happening at the Earth's surface. My research project itself is called Connect, and it's funded by the Environmental Protection Agency. And the objective of my research is to examine the connectivity between ground and surface water using remote sensing and geochemical tracing. So we know that groundwater is a major pathway of fresh water and potentially nutrients and pollution to surface waters. So we need to know where this groundwater discharge is occurring and whether it's bringing a significant pollution load with it. So first of all, we use temperature as a tracer, so that's our remote sensing. We use thermal imagery to pinpoint where the groundwater discharge might be occurring, because groundwater maintains a constant temperature year round, so it means when it discharges into lakes or coastal areas or rivers, it's actually much warmer than the surrounding water, and this is picked up in a remote sensing, in a thermal image. So once we know where the groundwater discharge is occurring, we then need to go in and verify that it is actually groundwater discharge and not some other process. So we use geochemical tracing. Particularly we use radon because radon is held in rocks and it goes into the water. So any water that's held within a rock has a very strong radon signal compared to, say, lake water or seawater. So the water that's immediately discharged has a very high radon signal. So we tour around in a boat with our radon monitor looking for signals of radon, and generally where we get peaks is where we're getting our groundwater discharge. So the kind of overall aim of the project is to improve our understanding of the connectivity between ground and surface water to help the Environmental Protection Agency, who are funding this research, to effectively manage these resources.